Alright, today's lesson is on algebraic expressions and collecting like terms. So remember from a couple of videos ago that we talked about algebraic expressions are made up of things called terms. So if you look at this down here, remember that terms were separated by a plus or minus sign. So this one has 1, 2, 3, 4, 5, 6 terms make up this algebraic expression. Also remember from the last video that to add and subtract variables, they must be like terms. And like terms means the exact same variable raised to the exact same exponent. And we're going to use both of those today to help in simplifying algebraic expressions. Remember that simplify means to make as small as possible. So remember from our first expressions video, we used order of operations to simplify expressions that don't have variables in them. Right? So we got it down to one single number. For algebraic expressions, it's a little bit different because we now have variables in them. We do this by collecting like terms. We know we can add the terms that are like, the ones with the exact same variables and the exact same exponents. And we use that to make our algebraic expressions a little bit smaller. Right? So our first step when a question asks you to simplify is to identify the like terms. So I'm going to do that by underlining. So let's start with our x squared terms. I'm going to do that with a single underline. Do we see any more? Right here is a like term. So we have 8x squared and 4x squared, and those are like terms. Then let's look at our 7x. So we have plus 7x, so I'm going to get that 2 underlines. And then we have negative 9x. So remember the sign that's in front of it goes with that term. So it's not just 9x, it's minus 9x or negative 9x. So those are the same. And then we have negative 3 and positive 5. Those are like terms. They both have degree 0. They're both numbers. We know we can add those together. We've been able to add those together since we were in kindergarten. Okay. Once we've identified the like terms, I'm going to rewrite it now with the like terms beside each other. Right? Order doesn't matter. We can switch the order around here, so I'm going to write them beside each other. So we'll write our x squared terms first, 8x squared plus 4x squared. Those are both things that are underlined once. Then we have plus 7x and minus 9x, and then minus 3 and plus 5. And that's equal to the line above it. Now we know we can add them together because they're like terms. So 8x squared and 4x squared. We add the coefficients, makes 12x squared. 7x minus 9x, said they were like terms. 7 minus 9 is negative 2, so we get negative 2x, and minus 3 plus 5, that's just your normal integer addition, so that's plus 2. Right? So this is simplified. This is as far as we go. Unlike just expressions that don't have letters in them, we're not going to get one single number a lot of the times, or one single term. But we can't go any further than this because we can't add and subtract these together because they're not like terms. One other important thing to know is the order which we write them in. We always write it from the highest degree to the lowest degree. It's just nice to have one consistent way of writing it. So we write our squared term first because the highest degree, then our x1 term, and then our constant term last, just to keep things consistent. Alright, hope you've had a chance to try these. So we have two different algebraic expressions here, and we've been asked to simplify them, and again we do that by collecting like terms. So our first step is to identify the like terms. So we start over here on our left. We have x squared. I'm going to try that again. We have 3x squared. And we want to find any other terms that are like terms, so the exact same variable, x, the exact same exponent 2. And we have one right here, minus 2x squared and minus 3x squared. We move along. X cubed, and a double underline that one. And we have no more x cubed terms here. And finally we have positive 5 and positive 7. Those have the exact same variable, nothing, the exact same exponent, nothing. Right. Once we have done that, we can add them together. No, I'm not going to rewrite it again. I'm going to save myself a step. So let's start with our x squared. So we have 3x squared minus 2x squared, so that leaves 1x squared minus 3x squared means negative 2x squared. Right. Again, I just did 3 minus 2 minus 3, and I'm just going to cross them off so I don't double count them. There is nothing to do with the x cubed, no other x cubed terms to add with it, so we just write it as is. And it's done. And then we have 5 and 7, which makes 13. Now, one more thing we have to do. We can't go any simpler than this, because we can't add any of these together. We have an x squared, an x cubed, and a constant term. But remember, we write it in degree order, so from the highest degree to the lowest degree. That means the x cubed has to come first. This would be 6x cubed minus 2x squared plus 13. And now it's simplified and written in the proper order. Finally, we do the exact same thing with question number 2. First step is to identify any like terms. So we have 12 xy squares. Do we have any other xy squares here? We don't. Be careful. This is an x squared y. Different than xy squared. Here the x has degree 1, the y has degree 2. Here the x has degree 2, the y has degree 1. So they're not the same. Same over here. We move along. Negative 8 x squared y. Do we have any other x squared y terms? Right here. Positive 13. And finally, we have negative 2yx and negative 7xy. Are they like terms? This one's xy. This one's yx. They actually are like terms, because multiplication is, the order doesn't matter. 2 times 3 is the same as 3 times 2. So we can change this around and write it as xy. The order doesn't matter. In general, we write it in alphabetical order within, but that was just to throw you off a little bit. So negative 2xy and negative 7xy. We've identified our like terms, now we add them together. There was nothing to go with the 12 xy squared. Now we look at our double underlines. Negative 8x squared y and 13. So negative 8 plus 13 is 5. So we have plus 5x squared y's. Cross all those out. And finally we have our xy's. Negative 2 minus 7 is negative 9xy.